All right, so there's still some of you that are a bit confused about unit conversions and how they work and how you set them up and everything. So I made this video for you guys. If you're still struggling with the idea of, how I set it up, where do I put things, why do I do this, this is the video for you. Okay, so a unit conversion, just to start with, a unit conversion is just a process of canceling units to go from one measurement to another. Okay, so one unit of measurement to another. So, for example, if I asked you, if I told you I worked for 2 hours, how many minutes is that? Right? We've got the unit of measure of time. We have got two different units. We have hours and we have minutes in this question. And so unit conversion would just be going from hours to minutes, figuring out how to do that. Now, in your head, you'd say, oh, you worked for 120 minutes because you know that 1 hour equals 60 minutes. So a lot of unit conversions that we do day to day come very natural to us because we know exactly what the unit conversion is, and we can do that math in our heads. But if I ask you to show your work, this is what is actually going on behind the scenes in your brain. You're taking 2 hours that you start with, and you're using a conversion factor. You're using that conversion factor of there's 60 minutes equals 1 hour, right? You're using that little fact of knowledge in order to figure out how many minutes there are in 2 hours, all right? In fact, you are taking 60 minutes, okay, and 1 hour. So 1 hour equals 60 minutes. And you're multiplying 2 times 160 to say, all right, you worked for 120 minutes. So this is exactly what's going on in your brain when you think of going from hours to minutes. Okay, this is just basically your brain spilled on paper. What we did was we took our conversion factor. So our conversion factor is any two things that are known to be equal. Okay, so any two things that are known to be equal is what a conversion factor is. So for in this case, we know that 60 minutes equals 1 hour. They are equal. So that conversion factor can be put in this little setup right here. So every time we are going to always make sure that our units cancel. In fact, in the definition of unit conversions, it says the process of canceling units to convert one unit of measure to another. Okay, so we start with what we're given, 2 hours, and we want to make sure that these hour units cancel. So the hours are going to go on the bottom, and the minutes are going to go on top. Our new unit is going to go on top. So every time, and when we do the math, we multiply on top, and then we divide by the bottom number, okay, like a big fraction, then we can get our answer. Okay, so there's a very easy or systematic way of doing unit conversions. Let me show you. All right, so when you are doing any kind of unit conversions, this is kind of the generic setup. You're always going to start with what you're given in the question. So this given unit is going to be from the question that you're asked. Okay, so from the question, you'll be given a number and a unit. You put the number here, and you put your unit there. Okay, the given unit. Then the question is always going to ask you, what new unit do you need to convert this to? And so to get to the new unit, again, you want to make sure that your conversion factor, this thing in green, okay, that's where your conversion factor is. Remember, conversion factor is any two measurements known to be equal to each other. All right, so you're going to set it up so that the given unit, okay, is on the bottom of the conversion factor so that when you do the math, they cancel. Okay, and they cancel because when you divide top and bottom, right, given unit divided by given unit equals 1. It goes away. Okay, and then the new unit, needs to be on the top. All right, so again, when you do the math, you're going to be doing given unit times new unit divided by given unit. The given unit's going to cancel, and you're going to end up with just the new unit in the end. All right, and then you'll obviously have a number to go with your new unit. Okay, so this is the generic setup every single time. So if you want to write this on the top of your paper, given unit times, and then the conversion factor, new unit over given unit equals new unit. That might help you out when setting up different problems. So let's take a look at a few practice problems, and then we'll go into actual mole problems. All right, so if we take a look at this question here, it says how many feet are in 4.5 yards, right? And we know that the conversion factor between feet and yards is 1 yard equals 3 feet. So using our generic setup that I just talked about last slide, what we can do is set up this conversion factor. We have our given unit and number. Okay, so our given unit and number is from the question, remember. So we do 4.5 yards is our given unit. And then we're going to set up our given unit again on the bottom. And our new unit's always what we need, what we're actually asked. So how many feet? That's our new unit. Okay, so feet goes on top. All right. And then we're going to put our numbers in. So you saw real quick, the first thing that I did when setting up this conversion factor was I put the units down first. That is super important. You must put the units down first because the units will drive where the numbers go. Okay. So the yards is on the bottom. So when I look at my conversion factor up here, 1 goes with yards. So that means 1 goes on the bottom. Okay, with the yards. They're like, tied to each other in essence. Okay, in the conversion factor, 3 goes with feet. And so the 3 goes on top with the feet unit. All right, so if this were reversed, if it said something about, how many yards are in 3.5 feet, well, then we would flip this. We would say feet on the bottom and yards on top, and those numbers would be flipped, right? The 1 would be on top and the 3 would be on the bottom. Okay, so this conversion factor can be flipped depending on what your given unit is. So you do need to make sure that every time you do a conversion factor, you are always setting up your units first, okay, because that will drive where the numbers go. Then, as soon as we've got everything set up, we're going to multiply on top and divide by the bottom. So we're going to do 4.5 times 3 divided by 1. And we're going to get 13.5. And now remember, our units, our given units cancel. The yards on top cancels with the yards on the bottom, so we end up with our new unit, feet. So how many feet are in 4.5 yards? Well, 13.5 feet. Okay, so let's use that generic setup again, and we'll do one more kind of generic practice problem, and then we'll take a look at the same thing using a new conversion factor, maybe not one that you regularly use in day-to-day life, but a new one with moles. All right, let's take a look at this one. How many years is 1,460 days? So again, using our generic unit conversion setup, we're going to start with the given unit, the one from the question, okay, which is 1,460 days, right? In order to convert it, we need our conversion factor, and the given unit days needs to be on the bottom, and the new unit, which is what we're asked for, how many years, needs to be on top. So years goes on top. All right. And this is a conversion factor that you hopefully have already memorized. There's 365 days in 1 year, right? So that means 365 is going where days goes in the conversion factor, and 1 goes where year goes in the conversion factor. So 1 year equals 365 days, right? Then we're going to do our math. We're going to multiply by the top numbers, divide by the bottom number. So 1,460 times 1 divided by 365 gives you 4 years, right? Making sure that the days cancel. So what we're left with is years, 4 years. All right, now let's take a look at similar types of problems, but with a newer concept for you guys. In chemistry, we call them moles. Okay, so a mole is a new counting unit. That's all it is. Okay, so just like a dozen, right, equals 12 of something, and a pair, we say, is 2 of something, a mole is 600 or 6.02 times 10 to the 23rd of something. Okay, so you could have a mole of donuts and you would have 6.02 times 10 to the 23rd, right? Remember, it's just a very huge number that is put in scientific notation so that we don't have to write out 21 zeros after that 2, okay? But all the mole is a counting number, just like dozen, pair, few, gross, like there's all kinds of different counting numbers, okay? So a mole is 6.02 times 10 to the 23rd of something. Now in chemistry, that something is going to be either atoms or molecules. That's what that something is going to refer to when we're talking about chemistry, right? So when we have a reaction like this, where we've got nitrogen and hydrogen gas reacting to form ammonia, NH3, what this is basically, this is a recipe telling how many moles of these molecules we need in order to make these many molecules of NH3. So for example, what this says, if we kind of write it out, is 1 mole of N2 plus 3 moles of H2 react to form 2 moles of NH3. Okay, so we can find the number of moles in a balanced chemical equation. These coefficients are the moles that are reacting in this reaction. Okay, so it's not the grams, it's not anything else. It is moles. Okay, so it's saying, hey, 6.02 times 10 to the 23rd molecules of N2, all right, plus whatever 3 times 6.02 times 10 to the 23rd molecules of H2, right, react to form 2 moles would be 12.04 times 10 to the 23 molecules of NH3. All right, so we can use these coefficients and represent them as moles of the compounds in a formula. Okay, so just like in the earlier ones where we kind of knew the conversion factors, like 1 year equals 365 days, or what was it? The 1 yard equals 3 feet. Those are common conversion factors. Okay, when we're talking about chemistry, and we're talking about a reaction in particular, where we get those numbers is from the chemical equation. Okay, so 1 mole of N2, okay, is what we need in order, to have this reaction occur. And 3 moles of H2 is what we need in order to have the reaction occur. So we can use these as conversion factors, these mole ratios. So when we are given a chemical reaction and we're asked how many moles of hydrogen are needed to completely react with 2 moles of nitrogen, we can think about it in the exact same way that we were doing before. We can figure out what our given unit is, and we can multiply it by a conversion factor where the given unit, right, is on the bottom, and our new unit is on the top. And we do some math, and we get a number with our new unit in the end, right? So the only difference is that the conversion factors are not coming from a 1 year equals 365 kind of source of knowledge. They are coming from these coefficients in the reaction. Okay, so we're basically using the recipe in order to figure out what that conversion factor is. Okay, so in this reaction, or in this question, I should say, it says how many moles of hydrogen, so hydrogen is going to be our new unit, are needed to completely react with 2 moles of nitrogen. This is what we're given. So the 2 moles of nitrogen, 2.0 moles of N2 is our given unit. And then we're going to set up our conversion factor where our given unit, moles of nitrogen, go on the bottom, right? And our new unit, moles of hydrogen, go on top, right? That's the moles of hydrogen. So we set it up, given unit on bottom, new unit on top, and then in order to figure out where these numbers come from, we take a look at the coefficients for the reaction. So let's see, nitrogen is 1, right? The coefficient is 1, so 1 goes on the bottom for nitrogen. And for hydrogen, the coefficient is 3, so 3 goes on the top with hydrogen. So then we're going to multiply on top, divide by the bottom number to get our final answer. 2 times 3 equals 6 moles hydrogen. Okay, making sure that our moles of nitrogen, moles of N2 cancel out. So you see it's very super important to make sure that you put the unit and the substance, okay, in your conversion factors, all right, because it's not just moles of anything, it's moles of nitrogen on bottom and moles of hydrogen on top. Okay, so we set it up the exact same way that we set up the other ones from everyday life. Start with our given unit, and then use our conversion factor to go from the given unit to the new unit. Okay, and we get these numbers, right? So we get those numbers from the coefficients in our chemical reaction. Coefficients in reaction. Okay, that's the only thing that's kind of new, okay, is where we get that information. All right, let's take a look at one more of these type of what we call mole-to-mole practice problems. So here we've got number 4. We've got a question. We're given a reaction. This is the reaction between C3H8 and oxygen to form carbon dioxide, and this actually should say water. Let's change that. Okay. So there's our balanced chemical reaction. What this means, or what this says, is 1 mole, 6.02 times 10 to the 23rd molecules of C3H8 plus 5 moles, 5 times 6.02 times 10 to the 23rd molecules of oxygen react to form 3 moles of carbon dioxide and 4 moles of water. Okay. So here's our question. How many moles of oxygen? So that's our new. Moles of oxygen is what we need to figure out. That's our new. Are necessary to react completely with 4 moles of propane. So that is our given. So we're given 4.0 moles of that C3H8, our propane. Right? So that's what we're going to start with. We're going to start with our given, and then we're going to put that given on the bottom, moles C3H8, and we're going to put our new unit, moles of oxygen, on top. That's what we're being asked in the question. All right? And then again, remember, these numbers that go in the fraction there come from the chemical reaction, right? The reaction coefficients. So those big numbers out front that we use to balance the equation. So for oxygen, it's 5. So 5 goes on top with the moles of oxygen. And for C3H8, it's 1. So 1 goes on the bottom there. Okay, then we do our math. We multiply on the top ones, divide by the bottom. 4 times 5, 20 moles of oxygen. Okay, making sure that the moles of CO3 are going to cancel out. Okay, so 20 moles of oxygen is what we're going to need in order to completely react with 4 moles of propane. All right, so those were a couple of examples for mole-to-mole type of conversions when we have a chemical reaction. But let's go back and talk about what a mole is and what are some equivalencies of moles, or some things that they're equal to. We talked about one, the 6.02 times 10 to the 23rd, but there's a second thing that the mole is equivalent to. And let's take a look at that. All right, so we talked about moles being equal to 6.02 times 10 to the 23rd. Okay, so that's just, again, two things that are known to be equal to each other. That's all a conversion factor is. Two units of measure known to be equal to each other. So in this case, the unit of measure being moles and the unit of measure being atoms or molecules. Okay, so 1 mole equals 6.02 times 10 to the 23rd. Okay, there's a second thing that a mole can be equivalent to, and that is the number of grams that you find on the periodic table. Okay, so scientists back in the day figured out that if they had an entire mole of a particular element, it was going to always weigh this particular amount. Okay, so if we literally counted up 6.02 times 10 to the 23rd atoms of carbon, let's say, then 6.02 times 10 to the 23rd atoms of carbon is going to be equivalent to this average atomic mass that we see on the periodic table, the 12.01 grams. Okay, so 1 mole is equal to that decimal number on the periodic table. Okay, so for carbon, 1 mole we would say is equal to 12.01 grams. Okay, for if we had sodium on the other hand, 1 mole of sodium atoms, that means 6.02 times 10 to the 23rd sodium atoms is going to be equivalent to 22.99 grams. So if we counted up that many atoms, then it would weigh on the scale 22.99 grams. Okay, so that's another conversion factor that we have with moles. So there's two of them. We've got 1 mole equals 6.02 times 10 to the 23rd atoms or molecules. And we have 2, 1 mole is equal to the grams on the periodic table. Okay, so we're going to use both of these. It just depends on what the question is asking for. Okay, so if the question is asking for us to solve for how many atoms or molecules, we're going to use this first one. If the question is asking for us to solve how many grams, then we're going to use the second one. It all depends on what it's asking for. So let's take a look at some of these examples. All right, so what if we were given this question? There are 0.011 moles of potassium in an average banana. How many atoms of potassium are in a banana? Okay, so the first thing we need to figure out is what is our given unit and number, and what are we trying to find, right? So our given is always the number and unit we start with. So this 0.011 moles of potassium, that's our given. And then we have to look at the question, how many atoms of potassium? So that's going to be our new unit, or what we need to find. So again, we're going to use the same setup. Given unit we start with. We're going to, in our conversion factor, put our given unit on the bottom, our new unit on top. Right? Okay, so for this one, we're going to start with our 0.011 moles of potassium. Potassium is K on the periodic table. And then we are going to put moles of potassium on the bottom so that they cancel when we do our math. Right? And then we're going to put our atoms, that's our new unit of potassium, on top. All right, now in this one we don't have a reaction to take a look at, but we do know some equivalencies with moles and grams that we need to keep in mind. So just like you know that 1 year is 365 days, you need to put in your mind 1 mole equals 6.02 times 10 to the 23rd atoms, okay? Because that's the unit you're going to use, or the conversion factor you're going to use. 6.02 times 10 to the 23rd atoms, because we're asked about atoms right now. Okay, now if it asked how many grams, then we would use the other mole conversion, which is the 1 mole equals however many grams are found on the periodic table. Okay, but in this case, we are doing atoms. So in this conversion factor, remember the unit and numbers stick together. So the 1 goes on the bottom with moles, and the top gets 6.02 times 10 to the 23rd, because that's what's sticking with atoms in our conversion factor. Okay, so what we need to do is we multiply the top, we divide by the bottom, so 0.011 times 6.02 times 10 to the 23rd divided by 1. And we're going to get 6.62 times 10 to the 21 atoms. Okay. In your calculator, please don't forget that this is an exponent. So make sure that you put the times 10 to the 21 in your answer. Otherwise, it's wrong. All right. It's vastly wrong because it's not just 6.62 atoms. You can't even see 6.62 atoms. There's no way you can have, put them on a scale and weigh anything, okay? So you need to make sure that whenever you are calculating and finding atoms, your answer should be gigantic. So gigantic, it has an exponent to it, okay? So because atoms are so tiny, we need a lot of them in order to work with them, okay? So please keep that in mind. All right, this last one that I'm going to go over with you guys is going to actually have us do a couple of conversions, okay? So it's going to, let's just read the question. It says, if 16 grams of sugar, so this is what we start with, okay? So 16 grams of sugar, that's our chemical formula for sugar, so this is what we're given, okay, are in a spoonful. How many molecules of sugar, so that's what we need to find, that's going to be our new unit, okay, are in this spoonful, okay? So sometimes we are going to be given a question like this where we can't go from our given to our new unit in one leap like this, just one little jump, okay? Sometimes we're going to have to extend this and do another conversion factor before we get to our new unit, what we're actually asked, all right? And that, just to kind of give you an example, okay, of maybe an everyday life kind of thing. If it said, how many centimeters are in 46 yards? Okay. I'm not sure anybody knows how many centimeters are in 1 yard, right? So we can't just jump from yards to centimeters unless we know that. What we would do is we would go, okay, well, I know how to get from yards to feet, and I know how to get from feet to centimeters, inches, and then I know how to get from inches to centimeters, right? There's 1 yard is 3 feet, right? 1 foot is 12 inches. 1 inch is 2.5 centimeters, right? So we've got several conversion factors that we would need to apply in order to figure out the answer to that. Okay, same goes with this one. If we look at the conversion factors we have for moles, we can either go from moles to atoms, right? Like this first one, moles to atoms, or we can go from moles to grams. But this question is asking us to go from grams to atoms, right? So that basically this guy is trying to, go from here to here, grams to atoms. We cannot do that in one step, okay? So what we're going to be doing is we're going to be expanding, okay, our setup here. So we're going to be starting with our given unit. And instead of going straight to the new unit, we need to go to this middle unit, right? So this kind of middle unit. And then from the middle unit, we can cancel that on the bottom and go to the new unit. Does that make sense? So we kind of have to go through this middleman. So it's like, up here when I said how many centimeters are in 46 yards, right? We can't jump from 46 yards straight to centimeters. What we need to do is go to these middle units first. We need to go to feet first, then inches first, then we can go to centimeters. It's the same thing here when we're working with grams to molecules, okay, or atoms. So we're still going to do our 16 grams to start with, C12H22O11. And if we take a look at our conversion factors, grams whatever grams C12H22O11 is, we can figure out how many moles that is, right? By looking on the periodic table. All right, so we're going to go from grams of this guy to moles. So grams is going to go on the bottom because we always need it to cancel. And moles of C12H22O11 go on top. That's going to be our middle unit, moles. In fact, moles, I always call them the middleman. He's going to be negotiating between grams and atoms or molecules. He's always the middleman. Okay, so if anything is, if we're not given moles, we're going to have to convert to moles eventually, all right, because moles is going to help us deal with both. So for this conversion factor, it's a moles and grams, so we're going to use this conversion factor here. 1 mole equals the grams on the periodic table. Right, now for this C12H22O11, what we're going to do is, what this means is we have 12 atoms of carbon. So we're going to do 12 times the carbon. So 12.01 times 12, right? 144.12, okay, grams. And then we have 22 H's, so we're going to take our hydrogen, and we're going to times that molar mass by 22, so 22.22. Okay, and then we are going to take our oxygens. We have 11 atoms of oxygen in this molecule, so we're going to multiply that by 11. So 16 times 11 is 176, right? And then we add them all together. We get 342.34. That's how many grams are in 1 mole of C12H22O11. So that grams is going to go on the bottom. So 342.34. And remember, that always equals 1 mole because we're talking about 6.02 times 10 to the 23rd. Okay, in 1 mole. So, so far we've gone from grams, we've canceled grams, and now we're in the mole unit. But remember, looking at our question, that is not where we're ending. We need to end with molecules. So that means we need to go from moles to molecules or atoms, right? So that means we're going to be using the next conversion factor. So remember, we said moles was our middle unit. Now we have to do another conversion to get to our new unit. So we're going to put moles of C12H22O11. And on the top, we're going to put our new unit, molecules of C12H22O11. And for this conversion factor, just like we said up here, remember, between moles and molecules, 1 mole equals 6.02 times 10 to the 23rd molecules. Right, so now moles cancels because we have a top and bottom moles, and we're left with molecules. Okay. So when we do our math, okay, we're going to multiply everything on top. So 16 times 1 times 6.02 times 10 to the 23rd, and then we're going to divide by the bottom, right? Our ones cancel, so we'll divide by 342.34. And in the end, we should get a very large number because remember, we're working with molecules, which are super tiny. So we want to make sure that we have a boatload of them in order to be able to see them. So in fact, we do get a very large number of them, 2.81 times 10 to the 22 molecules. Okay, so our final answer, 2.81 times 10 to the 22 molecules. All right, so that was a little bit more complicated just because we needed a second conversion factor to get from the given unit to the new unit, because sometimes we can't just jump straight from one to another. So hopefully that helps. And if not, just give me an email or post on discussion board, and I'll try to figure out another way to explain.